Hi everyone, this is Mrs. Ludis again, and I'm going to take you through topic number 16, which is equivalent expressions. Okay, once you get more comfortable with the SAT, you're going to see that this is one of those topics that they love to bring up on the SAT. So an equivalent expression is one where you have two different expressions that look different, but they simplify to be the same thing. Okay, so there are a lot of different ways to approach these problems. So I'm going to try to approach it several different ways. You can decide what works for you. Feel free to fast forward if you've already found a way that works for you. Another idea that I had for you today is if you want to try a problem before I go through it, then just pause the video and try it. I'm not going to leave any room in this video for you to say pause, try it, and then we'll go over it. So if you ever have the desire to do that, then that's probably a good idea. Okay, so for this first one, there's a lot of different things that we can do, okay? The first way would be to actually do the division. It's saying which of the following expressions is equivalent to that, okay? So it's dividing, right? So I know two different ways to do this. You could do synthetic division or you could do long division, okay? Personally, I would recommend synthetic division because long division is pretty time consuming, okay? So if we do a quick review with synthetic division, okay, I'm going to put the opposite sign of this value here in my backwards L, and then I'm going to list the coefficients of the divisor, okay, 12, 11, and -5. We bring down the first number, and the process is to multiply, then add. Okay, so you're always multiplying by the number that you put up here. So 1 times 12 is 12, that goes here. Add 11 plus 12 is 23. Can I do it again? 1 times 23 is 23, that goes here. Add -5 plus 23 is 18. Okay, this last number is your remainder. Okay, so if you look at our options over here, if you want to just check the remainder, you could. It's option A. Okay, the other thing I want to remind you of is if you're starting with a quadratic and you're dividing by a linear, then it's going to drop your answer by 1 degree. Okay, so my answer here, these represent the coefficients of our answer. 12x plus 23, and then this is our remainder. So plus the remainder over the divisor. Okay, so that's option A. Hopefully you have somewhat of a recollection of synthetic division. That would be helpful. Another way that we're going to go through a lot in this lesson is substituting in a value and simplifying the expression, then seeing which one of these options also simplifies to equal that number. Okay, so let's say we tried it that way. Okay, I'm going to plug in 0 for x. If I plug in 0 for x, 0 is a great number to plug in because it cancels everything, right? So these are gone. This is gone. Okay, so this expression here is going to simplify to be -5 over -1, which is +5. Okay, so now what I'm going to do is I'm going to go to all my answer choices. I'm going to plug in 0 for x, and I'm going to see which one also simplifies to be 5. Okay, we found that by doing synthetic division that our answer was A, but let me show you how I would also know this one is A. Okay, so if I plug in 0, this would be gone. This would be 0. So it would be 23 plus 18 over -1, which is -18. And I can see here that 23 minus 18 is 5. Okay, so if that happened to you, this is great to get it on the first try. It won't always happen. Let me just show you what happens when it doesn't. If I plug in 0 here, okay, it just ends up being just 23, which is not 5. So I would know that B is not my answer. Okay, then you're going to see that this is going to be a common technique that we're going to use with equivalent expressions. Okay, we're actually going to use it with our next one here, example 2. Okay, so this looks like a mess. I don't know if you guys feel that way, but I feel that way. Okay, so this equation is true for all values of x that does not equal 3 over a. Okay, we're looking for a. So if you notice in this equation, there are x's and there are a's. I don't want to plug in 0 this time. If I plug in 0 for x, guess what? A is also going to disappear, and then we can't solve for it. Okay, so the next best value to plug in is 1. Okay, so what I'm going to do is I'm going to plug in x is 1, and I'm going to simplify this expression, and then I'm going to be able to solve for A. Okay, so here we go. Every time I see an x, I'm going to plug in 1, which means all of those are just going to be 1, right? So 18 plus 51 minus 55. If that x is 1, then I just get a minus 3 over here. Okay, equals 9 plus 39, if that's going to be a 1, plus 62 over, and again, if that x is 1, then this will just be a minus 3. Okay, it looks a lot better, doesn't it, without having those x's in there? Okay, so now I'm going to simplify this. So 51 minus 55 is negative 4. 18 minus 4 is 14. Okay, 9 plus 39 is 48. Okay. One thing I notice here is that both of these fractions have a minus 3 as their denominators. Since they have like denominators, I can combine them. So I'm going to subtract over the 62 over a minus 3. 14 minus 62 then would be our numerator. A minus 3 is our common denominator. Okay. 14 minus 62 is negative 48. Okay, and then to finish this problem, I'm just going to cross multiply. Okay, so if I cross multiply here, I've got 48 times a minus 3. I'm going to keep those separate for now. Equals negative 48. Divide by this 48. I get a minus 3 equals negative 1. And then when I add 3, I get that a is 2. Okay, which is option C. Okay, so again, plug in a nice value. 0 is a good one. 1 is a good one. Okay, and then see, I mean, this one was just solving, but you're going to see later in this lesson where we're just going to simplify and see which one also simplifies to that answer. Okay, example 3 here. Couple choices. Again, you could plug in values. Okay, or this one actually isn't too bad to just kind of do. I don't know if you guys agree with me on that. We'll see. Okay, squaring something means to multiply it by itself, right? So I'm going to multiply c over 3 plus d over 2 times itself. Okay, and then I'm just going to FOIL. Okay, so here, this is going to be c squared over 9 plus cd over 6 plus cd over 6 again, and then finally plus d squared over 4. Okay, it looks kind of messy, but if you look at our answers, this is actually what our answer is going to look like. So I recommend with this one, since it's not too bad, to just do it this way instead of plugging in values. I actually think in that case it might be a little bit more time consuming. Okay, so I need to combine these. So I've got c squared over 9 plus cd over 6 plus cd over 6 is actually 2cd over 6. And then the only thing that's left to do is simplify this fraction. Okay, so I end up with c squared over 9 plus cd over 3. 2 over 6 reduces to 1/3 plus d squared over 4. Okay, so if I go look at my answer choices here, that looks like D. Okay, or you could follow the technique that we used with this one, where you plug in a value and see which one also simplifies. In this case, you would have to pick a value for both C and D if you wanted to do it that way. Okay, let's look at a few more example problems. Again, if you see one, they're like, oh, I'm pretty sure I could do that. Pause the video and try it, okay? So for this one is super simple. It's just subtracting polynomials, okay? So the one thing you have to be careful of here is to first distribute that negative, okay? It's going to change all of these signs. So plus 2x squared minus 3x plus 4, and then you're just combining like terms and putting it in standard form. So 5x squared plus 2x squared is 7x squared. Then I have a negative 3x. And then negative 1 plus 4 is 3. All right, so that is option A. Okay. Number 2, couple choices here. The first thing you could do is you could recognize this as something called a perfect square trinomial. Now, if you don't think you're going to remember that, then ignore this explanation. Okay, perfect square trinomial is where these are both perfect squares, and the middle is double their square roots multiplied together. Okay, that sounds confusing, but here's a shortcut for it. Okay, so what I'm going to do is I'm going to square root the first term. I'm going to square root the last term, and I'm going to steal this sign. Okay, a perfect square trinomial. If you think you could recognize that, this is great because look how fast that was. Okay, so it is option A. Okay, or your other option would be to do the equivalent expression. Sorry, not the equivalent, the substitution method. Okay, so what I'm going to do is if I plug in 1 for C and 2 for D, I'm going to see what this equals. And then we'll see which other one also equals that. Okay, so this is going to be 4 plus 20 times 1 times 4 plus 25 times 2 to the 4th is 16. Okay, so you would type that in your calculator. Okay, and that ends up being 484. Okay, so now what I'm going to do is I'm going to go see which other one of these also equals 484. Okay, again, you still have to continue to plug in 1 for C and 2 for D. So I'm going to put that over here. Okay, so if I do that, it's going to be 2 times 1 squared is 2, plus 5 times 2 squared is 4, so that's 20 squared. Okay. 22 squared actually does end up being 484. Okay, so that's another way to know that it's A. Okay, let me just show you one of the other options here. If I do this, 2 times 1 is 2, plus 5 times 2 is 10. This is 12 to the 4th power, which is going to be a huge number. Okay, just to give you, save you some time here, this one ends up being 54 to the 4th, and this one actually ends up being 104 squared. All of those numbers are going to be much, much larger than 484. Okay, but it is, that is an option. Okay, here's another one where it's totally up to you. A plus B plus C squared. Okay, you could multiply that out. A plus B plus C times A plus B plus C. This is actually one where I think it might be a good idea to do the equivalent expression of idea of substitution. Okay, so what I'm going to do is I'm going to plug in 1 for A, I'm going to plug in 2 for B, and I'm going to plug in 3 for C, and I'm going to see what I get. So for the initial expression, 1 plus 2 plus 3 squared. That's 6 squared, which is 36. Okay, so now let's go see which other one of these equals 36. Okay, now this first one's kind of long. It's kind of annoying. This is going to be 1. B squared is going to be 4. C squared is going to be 9. 2 times 1 times 2 is 4. 2 times 1 times 3. 2 times 1 times 3 is 6. And then 2 times 2 times 3 is 12. Okay, and if you add all those up, you do end up getting 36. Okay, now every single one I've done of those I feel like has been option A, which is like, oh yeah, then this one is great. Okay, obviously it's not always going to be that way. Like let's just check the second one. A squared is 1, B squared is 4, C squared is 9. That's going to add up to be 14, which is not 36. Okay, so that one can get annoying when the last option is your answer. But it's good technique. All right, one more here. Okay, this is actually very, very similar to what we did up here. Where is it? For example 2. Okay, so I'm actually going to follow the same technique here. I'm going to plug in 1 for x, and I'm going to simplify and solve for a. Okay, so this would be a good one maybe to pause and try by yourself since we already did one extremely similar to it. Okay. All right, so whether you did or did not pause, if I plug in 1 for x, I'm going to have 12 plus 8 minus 7 over a minus 1 equals 6 minus 1 plus 8 over a minus 1. Okay, again, all I did there was plug in 1 for x. Okay, let's simplify. It's going to be 13 over a minus 1 equals 5 plus 8 over a minus 1. Similar to last time, since these have the same denominator, I can go ahead and combine them. 13 minus 8 is 5 over a minus 1 equals 5. All right, and then I can go ahead and cross multiply. So 5 times a minus 1 equals 5. Divide by 5, a minus 1 equals 1. Add 1, a is 2. Okay, so again, this is one of those grid ends. You can put the 2 at the beginning or the end of the grid end. I usually just put it on at the back. Okay, and then bubble in your 2. Okay, so again, with equivalent expressions, you could actually do the math, like multiplying it out or dividing like we did on the first problem, or you can try this substitution technique where you pick values, plug them in, and see which one also equals that value. Okay, have a great day, you guys.